we'll be continuing with the same chapter, calorimetry. Last class I talked about principle of calorimetry. What was the principle of calorimetry? Heat lost is equal to heat gained. Hot body loses heat and the equal amount of heat is gained by the cold body, provided that there is no exchange of heat to the surroundings. Surrounding does not take part either in supplying or absorbing heat from the system of two bodies. Principle of calorimetry is also called method of mixture. Method of mixture. Here one hot body and cold body are mixed together, that is they are brought in contact. So hot body loses and the cold body gains. Principle of calorimetry is based on the law of conservation of energy. So till here we had done last time. So today we will continue with more theory part, and then last time I discussed about the resultant question based on the high specific capacity of water and based on the low or high thermal capacity of metals. Some resultant question we had already discussed; those are important. And now the another thing we are doing on here today is, you can give the heading effect of pressure and impurities on the MP and BP of a substance. This is our heading already. Effect of pressure and impurities on the MP. MP's full form is melting point. MP full form is melting point and BP's full form is boiling point. This melting point, what is melting point? We say it is the fixed temperature at which a solid changes into liquid. What is boiling point? You all know that boiling point of water is 100 degree and melting point of ice is 0 degree Celsius. That we all know the fact. What is boiling point? It is the fixed temperature at which a liquid changes into vapor or into a gas. That is called boiling point. So melting point value and the boiling point value of a substance will be affected due to increase of pressure and the addition of impurities. How are they affected? About that you are writing point number 1 you can write. MP melting point of a substance decreases. Melting point of a substance decreases with the increase of pressure and the addition of impurities and number 2, point number 2 writes BP. BP means boiling point of a substance. Boiling point of a substance increases. Boiling point of a substance increases with the increase of pressure and the addition of impurities and the addition of impurities. Okay, so please try to understand what you have written. Melting point, what happens to the melting point? We say it decreases when we increase the pressure and when we add impurities. What happens to the boiling point of the substance? Boiling point increases. This one is inversely proportional, but this one is directly proportional. This boiling point increases with the increase of pressure and the addition of impurities. So you may have some recent stat questions based on this fact. Now, for example, ice block on the ice block, when you increase the pressure, when you apply more pressure, you will find that the ice is melting faster than its normal rate. Because when you increase the pressure, the melting point decreases, hence the ice melts faster. That is the idea. Now, for example, you must have seen, suppose we are having a big block of ice, and on top of the big block of ice, we keep something, some heavy weight, some iron weight, heavy, we are keeping on top of it. You will find that the ice block will melt faster. That is, when the pressure increases, the melting point of the ice decreases and the ice melts quicker or faster. You must have seen the ice skater when they are skating on the ice rink. At the time when they jump on the ice block, they make mark, there will be marking over there. Why there is a mark? Because when they are jumping at a particular point, the pressure at that point on the block of ice increases. As a result, the melting point of the ice at that point decreases. So melting point decreases, the ice is melting over there. When the ice melts, it makes a mark. You must have seen that, so take a piece of knife and just press it over a block of ice. You will find that the piece of ice will be going inside. That means where you are exerting pressure, where the pressure is applied by the knife, there the ice will melt. And ice melts into water. In water, the knife can easily go inside. So you will find that the block of ice, the knife will be going into the block of ice easily and will be coming out from the other end. So the fact is that the melting point of ice decreases with the increase of pressure. Now the another thing, impurities. Impurities also affect the melting point. How? When we add impurities, the melting point again decreases. We are having a block of ice, put salt over it. You will find that the ice is melting faster. If the ice which is made is containing impurities, then that kind of ice will be melting faster than the pure ice. Pure ice does not contain impurities, so it will not melt quicker or melt faster. For example, we are having a piece of ice cream and the same amount of normal ice. Ice cream and a piece of normal ice on the same side, identical. Which one will melt faster, ice cream or the block of ice? Your answer will be ice cream. Ice cream will melt faster. Why? Because ice cream, when we are making, we are adding so many ingredients which are considered as impurities, means additional impurities, and additional things we are adding. That is not the pure water frozen. So it is the water mixed with something, some ingredients, maybe milk, maybe some dry nuts and all, whatever chocolates and all that you put there, sugar also you add, and then you will be freezing that water. That changes into ice. Ice block, the ice cream will melt faster. That is the idea. That is the reason why we have ice creams, as soon as you put on the tongues, it melts. It goes inside. Whereas the block of ice will be put there, it doesn't melt quickly. So it will take very, very long time, and that may cause tonsil and all that, cold. The person may be getting all those effects. So addition of impurities decreases the melting point of ice and the ice melts faster. So for the same reason, when there is a huge snowfall and the road gets blocked, the army people and all, they bring bag of salts and they will be sprinkling salts over the snows in order to melt them faster, and the snows will get melted faster and the road gets cleared. So that is in case of emergency they do, otherwise salt is also expensive. So that is the trick they apply. So that means the recent test questions, these type of questions may come and your answer will be based on this fact. The melting point of ice decreases with the increase of pressure when you are exerting pressure, and it also decreases when we add impurities to it. Then the ice, those kind of ice will be melting faster or will be melting quicker. So that is idea. Okay, now the second one, number 2, boiling point of a substance. What happens? We say boiling point of a substance increases with the increase of pressure and the addition of impurity. That is the kind of directly proportional. particularly we have to discuss about what happens to the boiling point of water. What is the normal boiling point of water? That is 100 degrees Celsius. Same as the melting point of pure ice is 0 degrees Celsius. But if the ice is not pure, the melting point will be less than 0 degrees Celsius. Same way, the pure water boils at 100 degrees Celsius, but if the water is impure, the boiling point will be higher than that. It will not be 100 degrees Celsius because boiling point increases with the addition of impurities. Same way, when pressure is increased, the boiling point also increases. For example, we are having a pressure cooker. There is a pressure cooker and you are having water in it. When you close the lid and you heat, you will find that the water inside the pressure cooker will be containing more amount of heat energy, because the boiling point inside the pressure cooker boils at a temperature higher than 100 degrees Celsius, because the boiling point will be more. So normal boiling point is 100 degrees Celsius, but within a pressure cooker the boiling point of water may be around 120, maybe around 125 degrees Celsius and all. Why? Because over there the pressure is more than the boiling point will change. Boiling point will rather increase, and that water will contain more amount of heat and can cook the food properly, can cook the food faster and also properly, because that kind of water contains more amount of heat energy. So that is the idea behind. So if question comes, why it is easier to cook food in a pressure cooker, we say in a pressure cooker the boiling point of water is more than 100 degrees Celsius, nearly 120 degrees Celsius, because with the increase of pressure the boiling point of water increases. That answer will be getting. So, and that water will contain more heat and will cook the food properly and faster. So that is why it is easier to cook food in pressure cooker. Normally it is difficult to cook food on a higher altitude, such as on the mountains, such as on the hills and all. It is little difficult. You know the reason why? Because at the higher altitude the pressure will be low, atmospheric pressure is low. So water's boiling point will be lesser than 100 degrees Celsius. It will be around 80, maybe 70, maybe 75, but anything but less than 100 degrees Celsius. That is, over here on the hills, the water will boil at a temperature less than 100 degrees Celsius. Then such water will contain less amount of heat and will not be able to cook the food properly. The food and all will remain raw. So that's why it is very important, it is almost compulsory to use pressure cooker on high altitudes, because pressure cooker will be increasing the boiling point of water, and now the water will be containing more amount of heat. So that is the idea. One year in Icse they had asked this question: a boy is boiling water and is dipping a thermometer inside it, and when he is boiling water, that is pure water, he was boiling, and he finds that the water boils at 120 degrees Celsius. How is that possible? Because we know the boiling point of water is 100 degrees Celsius, but now he records that temperature in the thermometer. As the water starts boiling, so that time the temperature was found to be 115, 110 degrees, this kind of temperature. How is that possible? The boy was surprised. Then that place where he was boiling water, pressure must be higher. Over there the atmospheric pressure must be more. So because of the increase of pressure, or he might be using a closed container. When you boil water in a closed container, the pressure will be more. That means the water will be boiling at a temperature higher than or more than 100 degrees Celsius. So he must be using a closed container. That is why it is happening like that. One thing you must have realized is that at home, when you boil water by closing the lid of the utensils container, then that water will be more energetic. I mean, will contain more amount of heat energy as compared to boiling water in an open container. Open container, the vapor will be going off there and the pressure will be less, but in a closed container, pressure is more. So that water will be having more amount of heat energy. So these are the result test questions you may expect on the basis of this fact. Now the another one, addition of impurities also will increase the boiling point of water. We'll be boiling water with impurities there already present, and we are boiling it, and we are boiling normal water, that is pure water, without adding any impurities. You will find that the Water which contains impurity will be taking longer time because it is going to absorb a large quantity of heat and will be more energetic, will contain more amount of heat energy than the normal water, than the pure water, because the addition of impurities also increases the boiling point of water. Making a cup of tea and just to boil a cup of water, this takes longer time. We say tea because in tea when we make, we will be adding all those ingredients and then we will be boiling that water. Milk, maybe the tea leaves and all those things you first add and then you boil in order to make a cup of tea. That takes longer time. To make pulses, the dal, it takes longer time just to, as compared to just boil water there. So because whether the impurities are there, so that impurities will increase or will be raising the boiling point of that water. So water will contain more amount of heat and it will take, in order to contain more amount of heat, it will take longer time. The idea, the recent tax questions may come on the fact, this fact, so which I already discussed. Which causes more severe burn? Just a normal water, hot water, or a cup of hot coffee or a hot tea? Which causes more severe burn on the lips? The answer is the coffee, because or maybe the cup of tea, because there the water is containing more amount of heat energy. Why it contains more amount of heat energy? Because in order to make a cup of tea or coffee, the water's boiling point is more. So that water is going to contain larger quantity of heat energy. So that will cause more severe burn. So hope you understood this part. So this topic is also over. Now the another topic is change of state. Change of state. What is the meaning of change of state? When we continuously heat a substance or we continuously cool a substance. Cool means you are absorbing heat from the substance, the body will get cooled. And when you are heating, that means the temperature will rise, that means you are supplying heat to a substance. You will find that apart from expansion or contraction, there will be change of states, physical state. That means maybe a solid may be changing into liquid and liquid may be changing into gas, and or the vice versa. There will be change of physical phase or physical state, that is known as change of state or change of phase of a substance. So we know the different type of processes are there. I think you know about it. What is melting point? We say melting point is the process. Melting. What is melting? Melting is the process in which a solid changes into a liquid at a fixed temperature. Change of state always takes place at a fixed temperature, that is at a constant temperature. At the time of change of state, temperature remains constant. Temperature does not change till the entire, the substance changes its state. Till then the temperature will remain stable or temperature will remain constant. For example, we are having a piece of ice, we will be supplying heat. So we know the melting point of ice is 0 degrees Celsius. That means when the will keep on supplying heat and the ice temperature will be changing, but at 0 degrees Celsius only, if the ice is pure, at 0 degrees Celsius, you will find that the temperature 0 degrees Celsius remains the same for quite some time, unless the entire ice melts into water. So then after once it changes into water, when once the change of state process is complete, then only the temperature will change. So either of them occurs at a time. Either the change of temperature by supplying heat or by withdrawing heat, or the change of state. Both do not occur simultaneously. Both do not take place simultaneously. One of them takes place at a time. Either the change of state or the change of temperature. Suppose we are having water. For example, we are having water at 20 degrees Celsius. We will be heating it. When you start heating this kind of water, 20 degrees Celsius, we know the boiling point of water. When you heat, then water will change into, ultimately will change into vapor or the steam. when you supply heat to the water at 20 degrees Celsius, we know the boiling point of water is fixed, that is how many degrees Celsius? 100 degrees Celsius, provided that it is pure and the temperature is pressure is normal. Pressure is normal. So boiling point is going to be 100. So from 20 degrees Celsius, you will find only temperature is changing from 20, it's going to 30, 40, 50, like this temperature is changing. If you are having a thermometer, there you can find the change. It will come up to 100 degrees Celsius. Once the temperature now becomes, that is the boiling point 100 degrees Celsius, you will find that you are supplying heat, yet the temperature 100 degrees Celsius is not increasing. It is not increasing. It remains the same. For quite some time, for quite long time, the temperature will remain same only 100 degrees Celsius. Once the water starts boiling and the entire water boils off, then only the temperature of this can change. Otherwise, the temperature will remain the same throughout. Same way, suppose you are having ice at minus 10 degrees Celsius. So keep on supplying it continuously. You will find that ice at minus 10 degrees Celsius, we know the melting point of ice is what? 0 degrees Celsius. So temperature, till the temperature of ice becomes 0 degrees Celsius, will keep on changing. Temperature will change because the state ice will remain but ice only. The ice will not be melting. You will not get any water from it. The ice will remain ice only till it comes to 0 degrees Celsius. Once it comes to 0 degrees Celsius, you keep on supplying it. You will find that the ice now starts melting. At that time, the temperature is stable. Temperature does not change until and unless the entire ice melts. The total quantity of ice melts. When it comes to 0 degrees Celsius, the ice will start melting slowly. First little bit, then little bit more, and then temperature remains the same. Temperature is not changing. Slowly it's melting like this. Once it melts fully, then the temperature after that will change. Once the ice melts, now the temperature of 0 degree, now it will become 1 degree, 2 degree, 3, 4, like that, keeps on increasing. And it will go up to 100 degrees Celsius. The another change of state, that is vapor. So 0 to 100 degrees Celsius, it will only rise of temperature, but the state is not. It will melt into water, and from air till air it will remain water. Once after it melts fully, then it comes to 100 degrees Celsius. There also you will find water will remain water. Water will not change into vapor immediately. So temperature remains constant. It will keep on absorbing large quantity of heat. Once it absorbs sufficient, then the water will slowly start changing into steam. Slowly. Little mass, then little more mass, like that will keep on changing till the entire water's mass changes into steam. And after that, if you are keeping in a closed container, then that steam's temperature further can be changed. That is called superheated steam. So this is all what I mean to say. At the time of change of state, when change of state is taking place, the temperature does not change. The temperature remains constant. Whereas when temperature is changing, that time the state will not change. The state will remain the same. They may ask the reason why it is so. The reason is say when you supply to a substance, this heat energy changes into both kinetic energy plus potential energy of the molecules of the body. Kinetic energy is related to change of temperature. Which kind of energy of the molecules of a substance is responsible for the change of state? The answer is kinetic energy. If kinetic energy is more, the temperature will be more. So this is the kinetic energy is the measure of temperature or rise of temperature. When kinetic energy is increasing, say 10 joule becomes 20 joule, that is the temperature will change. Then 20 to 30, the temperature will change, like that. But potential energy change takes place only when there is a change of state. That time the total amount of heat energy supplied will change, only the potential, whereas kinetic energy will remain the same. Maximum kinetic, all the molecules are having maximum kinetic energy. That means we cannot increase it by any more. So total energy remains, kinetic energy remains constant, that is temperature will remain constant, and whatever amount of heat we supply, that only increases its potential energy. So question may come even like this: during change of state, what happens to the amount of heat energy supplied to a substance? We say the amount of heat energy supplied to a substance increases the potential energy of the molecules only. And when there is a change of temperature or rise of temperature, what happens to the heat energy supplied? We say it increases the kinetic energy. This is change of temperature, this is change of state. Change of state. So either of them will change at a time. Both do not take changes at a time. Either kinetic energy will change or the potential energy will change. If kinetic energy changes, then we say that the state will remain the same, only temperature will change. But then potential energy changes, then we say that temperature, kinetic energy will not change, will remain the same. Then change of state will take place. So this is an important fact. So our today's lesson will be this much, and next day will be little bit is only left theoretical portion, and then we have to do the numerical problems in this chapter. So for today this one. Thank you for the day.